In this video, we're going to cover the second installment of surface area and volume, which is talking about changing the dimensions. When you're multiplying the dimensions by a certain number, that number is called the scale factor. So for example, if we were going to multiply these numbers by 2, the length, the width, and a height, 6 times 2 is 12, 5 times 2 is 10, 4 times 2 is 8, we would say that we multiplied all the dimensions by a scale factor of 2. So when we're changing the dimensions, this is what happens usually to the perimeter, the area, the surface area, and the volume. So the perimeter of the base, if we multiply the perimeter of the base by a scale factor of 2, okay, the original perimeter right here is 22. 6 plus 5 plus 6 plus 5 is 22. If we were to double that, right, and we were to make this 12 and this 10, 12 plus 10 plus 12 plus 10 is 44. Okay, now we could have just said 22 times 2 and got 44 without actually having to do that to the dimensions. Okay, for the area of the base, okay, the original area is length times width. 6 times 5 was 30. The new area of the base, if we take the scale factor, right, of 2, it's 12 and 10. 12 times 10 is 120. Okay, so we could do that, or the scale factor is squared. We square whatever the scale factor is. So since it's 2, 2 squared is 4. So we could take 30 times 4 and get 120 instead of having to actually change all of the dimensions. Okay, the surface area of the figure, the same thing. If we were to find the original surface area of this figure, actually let me erase this. Okay, if we were to find the original surface area, okay, the length, the width, and the height, we would get 148. Okay, if we were to double all of these, that would be 8. Our new surface area would be 592. Well, in the same way, surface area, we can just square the scale factor, which is 4. If we take 148 times 4, it would be 592. Okay, the volume of the figure, right? Area of the base times height, which is length times width times height. 6 times 5 times 4 is 120. If we doubled all of this, 12 times 10 times 8 is 960. Okay, or we could have taken the cube of 2. 2 cubed is 8. So if we took 120 times 8, that would have given us 960. So when we're given the regular dimensions, okay, so the perimeter of the base, for the perimeter, whatever the regular dimensions is, you're just going to multiply by the scale factor, so whatever it is. So let's say it's 2. You're going to multiply it times 2, which would be 44. For the area, you're going to multiply by the scale factor squared, or 2 squared, which is 4. 30 times 4 is 120. For surface area, okay, so any type of area, you're just going to square the scale factor. So 2 squared, which is 4. 148 times 4 is 592. For the volume, you're going to multiply by the scale factor cubed. So 2 cubed, which is 8. 120 times 8, which is 960, okay? This is just saying if the scale factor is doubled, okay? If we had wanted to reduce it by a third, right? Then instead of a 2, we would put a third. Instead of 2 squared, we would say 1/3 squared, which is 1/9. 1/3 squared, which is 1/9. 1/3 cubed, which is 127. Okay, so it just depends on what your scale factor is. Okay, so for example here, a rectangle has a perimeter of 22 meters and an area of 28 square meters. Okay, the perimeter is 22, area is 28. If you double the length and keep the width the same, what is the area of the scaled up rectangle? okay, the area. Now earlier we talked about changing all of the dimensions, okay? If we changed all of the dimensions, this is how you would go about doing it. Now, if we're only changing one of the dimensions, okay, then you just kind of have to look at the, let's look at the formula here, okay? Area equals length times width, okay? If we are going to double the length but keep the width the same, okay, double the length, 2 times L times W. Okay, see how this formula is just doubled, right? It's not squared. Okay, so uh, all that we would do here now is multiply it by 2. Okay, we would not multiply it by 2 squared. Okay, so here the area is 28. So we're going to take 28 times 2, which is 56. So this would be 56 square meters. Now this says if you double the length and the width, what are the perimeter and area of the scaled up figure? Okay, so for the now it's saying we want to double the length and the width. So our new formula is 2L 2W. Okay, 2 times 2 is 4, so that's 4LW. So now notice how this formula is quadrupled, right? We took the square of 2. 2 times 2 is 4. So the new area for this figure, you would take 28 times 4, which is 112 meters squared. Okay, the perimeter, remember, because here we're doubling all of the dimensions. Okay, so we can go back to this table, right? Perimeter, we multiply by the scale factor. If the scale factor is double, right, we're doubling it, then it would be 56 meters. Oh, doubling it, sorry. 22 times 2 is 44 meters. So this would be the new perimeter. This would be the new area. Here it says a rectangular prism has a surface area of 486 square centimeters and a volume of 729 cubic centimeters. What is the volume if only the length of the original prism is reduced to 1/3 of its original size? Okay, so earlier, remember how we talked about volume? When we said if you change all of the dimensions, okay, that means length, width, and height. Okay, then you would cube the scale factor because, like, for example, here it says reduce it by a third. So if we were going to reduce all of them by a third, right, then we could have 1/3 times 1/3 times 1/3, which is 1/3 cubed, or 1/27. Okay, but it's only telling us to that the length is reduced by a third. So our new formula is 1/3 length times width times height. Okay, so all we're going to do here for the new volume is multiply it by a third. So we're going to take 729 and multiply it by a third, or divide by 3, which is 243 cubic centimeters. This says a right rectangular prism has a volume of 480 cubic centimeters. What is the volume of a new prism if the length of the original prism is doubled? Okay, so length times width times height. Only the length is doubled. Okay, so all we're going to do is just double the volume. Okay, so we're going to take 480 plus 480 is 960. So it would be 960 meters cubed. Okay, this last one says find the surface area to volume ratio of the rectangular prism shown here. Okay, surface area to volume is just comparing how surface area and volume relate to each other. So what you have to do is find the surface area and then find the volume and then compare them. Write them in ratio form, right? Write them as a fraction. So surface area, we have the perimeter of the base, okay, our base is a rectangle, 5 plus 2 is 7, plus 5 plus 2 is 14, times that by the height, which is 3, okay, 2 times the area of the base, which is 10. So now we're going to take 14 times 3, which is 42, plus 2 times 10, which is 20. So that's going to give us 62. The volume, okay, area of the base, 5 times 2 is 10, times height, which is 3. 10 times 3 is 30. Okay, so now we're going to take 62 over 30. And remember, we always want to reduce it down as much as we can. So that's going to reduce down to 31 over 15. Okay, that's the surface area to volume ratio. And that is the end of surface area and volume part 2.